Okay guys, so here is a new device that I've decided to try to make your learning a bit easier. In order to try it out, I've decided to go into the questions that you did for your test the other week and see, I'll use it as my, kind of to try and figure it out how this device works. Already I tried it out and, the sound wasn't working. That's because of my issues with technology. But let's see again if this is going to work for us. Let's try this out with the last assessment tasks you guys had. And here it is. This was question 1 of CAT 003. I've split this question up. We're going to do all the questions, but I've split this one up so that we can tackle each part separately. So this is part A, just requires us to factorize a quadratic expression, MYP, MYP4, MYP5 kind of material. And then, of course, we need that information or that knowledge to be able to find the partial fractions for the subsequent part B. Yeah? I've split up this so that we can answer them separately, as you can see. So part 1, for the sake of a student in MYP4, MYP5, particularly the extended class, who may not have learned how to factorize a quadratic expression, I'm going to just, go through it. A general quadratic expression is expressed as ax squared plus bx plus c, where a, b, and c are constants. A is the coefficient of x squared, b is called the coefficient of x, and c is the constant. In our expression, we can see that the value of a is 1 because there is only one x squared. The value of b is -3, and the value of c is -10. So if we're going to factorize this, we need something called the product, which is found by taking the value of a and multiplying by the value of c. In our case, the product is 1 times -10, which is -10. There's also something called the sum, which is simply the value of b. In our case, the value of b is -3. So having found the sum and product, we need two integers whose product will give us -10 and whose sum will give us -3. And so these numbers, if you check carefully, should be 2 and -5. And the reason we need to find this is so as to help us spread or split up this term. And in our case, that would be the term -3x. We need to split that term up, so we end up with 4 terms that we can then split up in pairs. Right? So looking at that, we can see that our quadratic expression therefore becomes x squared, and instead of -3x or -3x, we will put plus 2x, and then we will put -5x, and then, so now we've split up the 3x, and now we can put our -10. So this is equivalent to -3x, but we split like this so that we can take 2 in turn and factorize. So if we look at the first 2, x is common, so we can take x outside, and we have x plus 2. Okay. Looking at the next 2, -5 is common, so we have x plus 2. Always the terms in bracket will be the same. Now looking at it, we can see x plus 2 is common here, and therefore we can factorize it out, and we have x plus 2 into x minus 5. And so we factorize the term in part A. This should be about a mark or 2 in the diploma program, a method mark perhaps, and then the answer mark. Now, part B requires us to then find the partial fractions for that rational function f of x. We are going to make use of that denominator. In place of this denominator, we will make use of the result that we've got. So we can write our f of x as x minus 19 equals divide by x plus 2 and x minus 5. That's what we have. And this must be equal to a over x plus a, small letter a. If we compare that with what we've had on this side, which is here, this should be plus 2. So the lowercase a is positive 2 minus uppercase b over x minus lowercase b. If we compare that here, we see that has to be 5. Combining this together and skipping one step, we can express this as x minus 19 is equivalent to a into x minus 5, so a times that, minus b into x plus 2. All right. Now, to find the values of a and b, there are two methods, but the easiest method here is, of course, to simply eliminate one value, eliminate a and find the value of b, and then eliminate b and find the value of a. To eliminate a, we need to make this a 5. We need to turn this bracket into a 0. So to do that, x needs to be 5. So we let x be 5. If we do that, then now the left-hand side of this expression here becomes negative 14. And the right-hand side, this has gone. And so we end up with minus of b into 5 plus 7 plus 2, which is 7. And that gives me a value of b as positive 2. So I found b by eliminating a. Similarly, we can eliminate b to find the value of a. So if we make if we make x negative 2 here, this term becomes 0. So then if we put negative 2, we let x be negative 2. If we put negative 2 here, we get negative 21 must be equivalent to, now b is gone, so we have a into negative 2 here becomes negative 7, and solving that gives us a equals 3. And this means that our partial expression, so x, therefore, this implies that x minus 19 divided by x squared minus 3x minus 10 can be expressed as a, our value of a is 3, so 3 over x plus 2, minus the value of b is 2, so 2 over x minus 5. And we have expressed our rational function as partial fractions. The use of partial fractions will become useful when we start integration, and when you're asked to integrate a function like this, sometimes it's easier to split it up into partial fractions like this, which then becomes straightforward in the process of integration. Thank you very much. We'll go to the next question. All right, so here is the second question. The cubic function f of x is ax cubed plus 12x squared minus 21x plus b has 3 real roots. It is divisible by x plus 1, and the product of the roots is 10. So there are actually two things to look at here. The fact that it has got 3 real roots, and the fact that it is divisible by x plus 1, as well as that the product of the roots is 10. So we are looking at several things here. The Vieta's formula to help us talk about product of roots. And we are also thinking of factor and remainder theorem in order to be able to determine the values of a and b. Okay, so the first part of the question is find the value of a and the value of b, find the sum of the 3 roots, and find the remainder when f of x is divided by x plus x minus 1. So 2 areas here, once again. One is factor and remainder theorem are going to be used here. And the second thing is Vieta's rule for sum and product of roots of a polynomial. Okay, so again, I've split this question into 3 parts. Let's start with the first part. To find the values of a and the values of b. So to understand this, let's remind ourselves of what the factor theorem says and what the remainder theorem says. So factor theorem, let's start with the factor theorem. So factor theorem says that if x minus a is a factor, if this is a factor of f of x, then f of a has to be 0. Okay, so that is the factor theorem. Yep. Okay, that's the factor theorem. How can we make use of the factor theorem here? Well, we are told that f of x is divisible by x plus 1. So since it is divisible by x plus 1, so x plus 1 is a factor, implies that f of negative 1 has to be equal to 0. So that tells me that I can simply say that f of negative 1 which is equal to a into negative 1 cubed plus 12 into negative 1 squared minus 21 into negative 1 plus b. This has to be equal to 0 by factor theorem. This is negative a plus 12 plus 21 plus b is 0. I can conclude that b minus a has to be negative 33, and that becomes my first equation. The second thing that I need to make use of is the fact that the product of the roots is 10. Now by Vieta's law, so Vieta law, which we have compressed into a much tighter formula, we write s of I equals negative 1 to the power of I into a power n minus I, everything over a n. Right? So in our case, this is a cubic function, and we are looking for S1, the product of roots, so we are looking for S3, really. Therefore, the sum, the product of the roots, that's S3, which should be equal to first root times second root times third root. This is going to give us 10, but by this rule here, that would be the same as negative 1 power 3 into 3 minus 3, so a naught over a3. In our case, this is negative of a naught refers to, when we look at the polynomial there, a naught refers to the value of b here. Okay, so that is b. Okay, and a3 refers to the value of a right here, and so that is b over a. So we can conclude then that minus b over a is 10, this 10 here, and therefore b is negative 10a. This would be our equation number 2. When we solve equation 1 and equation 2 together, we should be able to get the value of a and the value of b. We can do that easily by substituting 2 into 1. So we remove the value of b there and substitute there. I'll use a different color. This becomes, so in place of b, I'll put negative 10a. Therefore, negative 10a minus a must be negative 33. So clearly a is 3. The value of a is 3. This is negative 11 is 33. So negative 33 over negative 11 should be 3. So that's the value of a. Substitute that into equation 2 and therefore b is minus 10 into 3, negative 30. So this is the value of b. So that is part A of the problem. We go to part B. Okay, so part B of the question requires us to find the sum of the three roots. Well, we know now that from the previous part we found, for example, that the value of A was 3 and the value of B was negative 30. Therefore, our polynomial function can now be expressed as 3x cubed plus 12x squared minus 21x minus 30, right? By Vieta's rule, which we've already written down, let me write that down again. By Vieta's rule, SI is minus 1 power I into an minus I over an. So the sum of the root, that means the sum of singles, so it's S1 because it's R1 plus R2 plus R3, so it's the sum of 1, so that means S of 1. S of 1, which is R1 plus R2 plus R3, must be equal to 3 minus 1, so that means A2 over A3. As a matter of fact, we should write minus 1 power 1 for that, and then this is A2, and our A2 is 12, so this is 12 divided by A3, which is 3. And so the sum of the roots, the sum of singles, R1 plus R2 plus R3, has to be minus 4. Okay, let's see if we can push this into the third part of the question. The third part, which is C, says to find the remainder when f of x is divided by x minus 1. Now we need the remainder theorem. And the remainder theorem states that, remainder theorem states that if x minus a leaves a remainder r, when f of x is divided by that, then f of a is going to be r. So therefore, if we are dividing by x minus 1 and we get a remainder, and the remainder is r, so if this gives r, then we are saying f of 1 must be r. Well, f of 1 from there, we are now substituting into this function here. So f of 1 gives me 3 into 1 plus 12 minus 21 minus 30, and this has to be equal to r. What is that? So this is negative 51. Negative 51 minus 15, is that 36? Minus 51 and 15, so 11, 6, yes. So that gives us negative 36. I can quickly erase this. And so we get a remainder of negative 36. Okay, thank you very much. We'll move to question number 3. Right, so here is question number 3. This one is about sketching curves specifically rational functions. Find the equation of all the asymptotes, vertical, horizontal, or oblique for the following function. So the first one, f of x, x minus 1 over that. So for the first one, so f of x is given to us as x minus 1 divided by, I'm just rewriting it again, 2x minus 1 and x plus 1. Right, how do we, so when we look at this, we can see the denominator is quadratic, the numerator is linear. So immediately based on that, we know if the order of the numerator is smaller than the order of the denominator, then we know that the horizontal asymptote is actually the x-axis. That is the line y equals 0. So since if we refer to this as p of x, Pn of x, and this here as Qn, Qm of x, then we can see that n, the order n, is less than the order m, and therefore the horizontal asymptote has to be line y equals 0. If you like, you can say the x-axis. Okay. Usually we will be asked to write down the equation of the asymptote. So when you're asked to determine the asymptotes, usually you write down the equation, and as it says here, write down the equation of the asymptote. So this has to be the line y equals 0. Okay, this is part A of the problem. Now let's find the vertical asymptotes. To find the vertical asymptotes, we look at the denominator, and we reason that if the denominator is 0, then we are having an undefined function. F of x becomes undefined, and because of that, any value of x that will turn the function or make the function undefined, that value of x will tell us what the vertical asymptote is. Okay, so clearly by just looking at the denominator, we can see that if x is a half, if we make x a half, then we'll end up with 1 minus 1, and that cancel the whole of the denominator, makes it 0. So we can reason straight away that one of the values of the vertical asymptotes are the line x is 1/2. Okay, that's one value. The second value we can get by looking at the next factor. So what value of x do we put here to turn this into a 0 and therefore render the denominator as 0? That would have to be x equals -1. So the line x equals -1 is our second vertical asymptote. So we have two vertical asymptotes there. Yeah. The second polynomial, or the second rational function, is a bit different. So let me just remove this so we can see it clearly. Right. So the second one is a bit requires a bit more. So if we look at the function now, part B, g of x is now 4x squared minus 4x plus 2 over 2x minus 1. And now you can see that if this is a Pn of x, and this one here is a Qn of x, polynomial of order m, okay, then you can see that the order n, this is squared, and this one is power 1. So the numerator is now at a higher order compared to the denominator, and for that reason, so since n is greater than m, we will have an oblique asymptote. Okay, we end up with this implies oblique asymptote. Okay. How do we find that oblique asymptote? That is in addition to the vertical asymptote. There is a vertical asymptote determined from the denominator. The same way we determine that, Okay, we have that there, vertical asymptote. But we no longer have a horizontal asymptote like we had there, and that is because now the order of the polynomial, the numerator, is greater than the denominator. So to find the oblique asymptote, we have to divide these two, and we use the method of long division. So I'm going to conduct long division very quickly here, the same way we divide numbers. So we have 2x minus 1 there, and we have 4x squared minus 4x plus 2. If we divide this, we get 2x goes into 4x squared 2x times. If we multiply back, we get 4x squared minus 2x. Now we have to subtract those two, and that leaves us with negative 2x. When we subtract, bring the 2 down, this 2 here, right? So 2x goes into negative 2x, negative 1 times, to give us negative 2x plus 1. Okay, and if we subtract this, we end up with 1 there. What this means, what this is telling us here, is that that g of x can now be expressed as 2x minus 1, and then we will say plus a remainder which is 1 over the divisor, which is 2x minus 1, like that. And from this, we know that this number here is our oblique asymptote. So the equation of the oblique asymptote is the line y is 2x minus 1. The value of the vertical asymptote can still be found. The vertical asymptote is found by determining the value of x that will render the denominator as 0, and again we can see that is the line x equals 1/2. Okay, so these are the solutions to question number 3. Okay, let's now move on to question number 4. So here is question number 4. This is an absolute function. F of x is x plus 2 absolute minus x minus 1 absolute plus 1. The part 1 is asking you to sketch the graph on the grid that is provided. This is pretty straightforward. Since we are not using a calculator, all you need to do is to find a few values, plot a few values of this function. For some values of x, find the values of f of x. So pick a few values of x and find f of x. And we can start with, let's say, -5. So what happens when x is -5? When x is -5, let me write this here. We have f of x equals x plus 2 modulus minus x minus 1 modulus plus 1. So when x is -5, we have -5 there and there. That is -3, which becomes +3 when we take the modulus. So 3, and then we have minus. We have -5 there, -5, and that is -6. Put together is +6, so we are subtracting +6 and then adding 1. If you check that, you can see that this gives us a total of -2, right? Let's pick another point, maybe 3. I think 3 is good enough. If we take -3, put -3 there, we get 1, +1, yeah, minus, put -3, that's -4, so minus +4, and then +1, we get -2. Let's try -2. -2 gives us what? -2, that is 0, minus 2 gives us, so 0 minus negative 2 is negative 3, which becomes positive 3, plus 1 gives me negative 2. Okay, negative 1, what does negative 1 give me? Gives me positive 1 here, minus negative 1 here is negative 2, so positive 2, and then plus 1, and I get 0. Is that right? Yes, I get a 0. And then at 0, when x is 0, I have 2 minus positive 1 plus 1. So I get a 2. And when I have a 1, when x is 1, I end up with 3, 0 plus 1. So 0, I can write minus 0 here. That's terrible. So 1 is 3 minus, and this is 0, and then plus 1, and I get 4. And if I put a 2 there, I get a 4 minus 2 here leaves me with 1 plus 1, and I get a 4, like that. So I imagine the rests are going to give me 4s. And so if I can plot this point, so negative 5 here, when x is negative 5, y is negative 2, which is somewhere here. Okay, that's my first point there. When x is negative 3, y is negative 2, so negative 3 is also to negative 2 there. You can see that also there. Yeah. When x is negative 1, y is 0. So when x is negative 1, did we do negative 2? We did negative 3. Negative 2 is negative 2 as well, so that also gives me this. But at negative 1 we have 0. Yes, at negative 1 we have 0 there. Negative 1. And at 0 we have 2. So at 0 we have 2 right there. At 1 we have 4. So at 1, which is here, we get 4, which is right there. Okay, and after that it becomes 4. So at 2 it's also 4. So this is 2 here, takes me to 4. When you draw this graph, you can see we end up with a straight line like this, like that, and then it continues as a straight line this way, like that. Okay, that doesn't look nice. A better horizontal line that goes like that and continues that way. So that would be the graph that was expected out of you for this question. Part B was to write down the value of f of 0. I believe we already did that. F of 0 is here. F of 0 is 2. And f of negative 1 is 0. So f of negative 1, which was this one here, which is this one here. F of negative 1, which we found was 0, which is 0. This is 0 here, f of negative 1. And f of 0 is 2, which is here. That's this part here. Yeah. And so the last question says, hence find the values of x for which f of x lies between 0 and negative 0 and 2. And clearly the values of x, so this is for part C, the values of x must lie between. less than or equal to -1 greater than 0. Okay, and so that would be the answer to question 4. Okay, we'll look at question 5 next. Now to answer question 5, the first thing you need to do is actually to combine the two terms on either side of the equation together instead of cross multiplication, really. So I could write this simply as x squared plus 10x over, what is that? X plus 1 into x minus 3, and bring the other one to this side. So we have plus 25 over x plus 1, x minus 3, and say that is less than or equal to 0. So clearly when you add this, you will get x squared plus 10x plus 25 is greater than or equal to 0. Yeah. Now, this already tells me that the value of x, one of the possible, because of the less than or equal to here, one of the potential values of x is 5, because this is a perfect square, so we can write this as x plus 5 squared is less than or equal to 0, which is to say x is -5 is one of the potential, one of the solutions. One of the possible values is x equal to -5. This is one of the possible solutions. Okay, but the next thing we want to do is to then draw what we refer to as a sign diagram for this function here. So we have, so the next thing is to do a sign diagram. Okay, so a sign diagram means, so first of all, looking at this expression, let me write the whole expression, and then we do a sign diagram. I can write this as x minus 5 squared over x plus 1 and x minus 3, and this has to be less than or equal to 0. So we want places where this becomes less than or equal to 0, and to do this we draw a sign diagram. On the sign diagram, we want the point where x is, we want to know at 0 what's going on, but we have asymptotes at -1 and +3, so we draw dotted lines -1 to remind us of where the asymptote is, and another one at 3. We want to know what's going on in here. We know that a value of -5 is already a solution, so that's one of our solutions. Now we want to know where the function is here, because we want to see where this whole function is less than 1. So when x is any number lying between -5 and -1, put negative, for example, -2, put -2 there, we get -7 squared, which is positive. The denominator is -2, and that is -1. And the numerator is -2, and that which is -5. So clearly the denominator is positive and the numerator is positive, so the function is positive here. Right? Somewhere between -1 and 0, we can use -0.5. So we put -0.5 there, so that becomes -5.5 squared, which is positive. This becomes, we're putting -0.5, so this becomes -0.5. Put negative there, and this is -3.5. So again, the numerator is positive, the denominator is positive, so the function appears to be, so negative there, -3.5. This is positive. This here is positive because that's -0.5. So this is positive, and that makes the denominator negative, the numerator is positive, and so clearly the function is negative at this point, right? Between 0 and 3, we can use 1, substitute 1 there, we get negative 4 squared in the numerator. In the denominator, we are putting 1. Okay, so we get 2 there, and put 1 there, we get negative 2. And so the denominator is negative, the numerator is positive, so the result is negative. We go beyond, and we can put a 4 there. If we place 4 here, we get negative 1 squared, which is positive. The numerator is always positive. The denominator, if we put a 4 there, we have 5. And put 4 here, we have 1. So the denominator is positive, the numerator is positive, so this becomes positive. So we can see that the function is less than 0. That means it's negative. This means negative. So the function is negative between negative 1 and 3. So we can say that the solutions therefore are x other than this. The other solution has to be x lies between negative 1 and positive 3. Okay, so this and x equals negative 5 are the solutions to this problem. Okay, all right, that leaves us with question 6 and question 7. So we move on to question number 6. So here is question number 6. The graph of the function y f of x is given below, right? This is a rational function. The question is for us to sketch the graph of the reciprocal function. Now we're supposed to do it on this grid, but we will draw it against the function itself because it makes life easier for you. Okay, so the things that we need to remember in order to be able to draw the graph of the reciprocal function are 3 things. One is to look at the asymptotes. So the first thing is to think about what's going on with the asymptote. So let's think about asymptotes. Okay, so at this point, at the value of x equals negative 4 and x equals 3 are vertical asymptotes. Okay, so this would be the line. Let me write it here. This is the line x. This is the line x equals negative 4. And this here is the line x equals 3. That's a vertical asymptote. Then we also have a horizontal asymptote here, which is the line y, the value of y. Let me write it right here. The value of y is always equal to 2. So line y equals 2. So we need to think about what's going on with these 3 asymptotes. Okay. Now let's think about this in terms of the function that we have. Now, at the value x equals negative 4, this being an asymptote implies that the value of y here increases to infinity, positive infinity, and on this side it decreases to negative infinity. So let's think about that in the context of the function y is 6 divided by f of x. So if f of x, so at the asymptote, f of x is either positive or negative infinity. And that means our value of y, which is the reciprocal function, is going to be positive or negative 6 over infinity, or 6 over positive or negative infinity. I can write that down easily here. I can remove that and put in its place plus minus infinity down there. It doesn't really matter. The result of that is that the value of y is going to be 0. So effectively what we are saying is that at this point here, our reciprocal function will pass through line y equals 0. That means the x-axis. Similarly, it will pass through this point because here also the value of the function is infinite. Okay, so that is sorted. That is the first point to remember. The second point that we want to remember is that the horizontal asymptote, so horizontal asymptote occurs at y is 2. And therefore, for the reciprocal function, the asymptote must occur at the line y is 6 over 2, which is 3. So we expect to have a horizontal asymptote. I will use pink to draw our new horizontal asymptote for the reciprocal function. Must pass through this point here, like that, to the other end. That's our horizontal asymptote. Also, point number 3, the graph will pass through, our line passes, our graph here, function passes through the x-axis at this point here, and again at that point there. So let's think about the value of y at the x-intercept. So at the x-intercept, f of x, the value of f of x is 0, and therefore the value of our reciprocal function is going to be 6 divided by 0, which is going to be undefined or infinite. So we expect that at the intercepts of our function f of x, the value of the reciprocal function will be infinite. It suggests that the reciprocal function will have its vertical asymptotes at this point. So I'm going to put the vertical asymptotes. Again, let me use pink so that we know this clearly refers to the vertical asymptote. So there is a vertical asymptote here, right, and down. And there is a vertical asymptote here. Right, and down, like that. Now we are ready to sketch our function. One more thing, but this is kind of common sense, is to understand that where the function is increasing, the reciprocal function should be decreasing, and where the function is decreasing, the reciprocal function should be increasing. Okay, and therefore, because of that, looking at this function here, as the function decreases, that means as we go towards the negative x-axis, the reciprocal function should be increasing and increasing towards the 3. So, all right, and on the other hand, the function is increasing, so I expect the reciprocal function to be decreasing towards this point here. And so my graph should look like this. Like that, a curve that passes through the x-axis here at 0, and as you can see with this graph here the graph is approaching 0, so the function should be increasing but in the negative direction, so the graph should go down there. And this makes sense because on this side the function is increasing, so the reciprocal should be decreasing, approaching 0. Okay, so this is our reciprocal function, this part of the reciprocal function. That would take care of this, as well as this section here is taken care of. We're left with this. Let's go up to the value x equal to 3. So we can see here that at this point the function is 0. So that means the reciprocal function should be infinite and positive, because this section here is on the positive side. The function increases at the value of x equals 2. The value of function equals 2. That means at x is equal to 0, the value of the function is 2. So the value of the reciprocal function should be 6 over 2, which is 3. So we expect our reciprocal function to pass through this point, increasing from infinity, decreasing to that point, passing through 3, and the function here is increasing, so I expect my function to decrease towards 0, and then the function is now negative here. As you can see, the value of the function is negative beyond this point. So I expect this to go below. Same thing that happened earlier, right? And the other side to increase, this side to increase and the other side to decrease towards 3. As that function is increasing, this reciprocal function should be decreasing towards line y equals 3. So this is our line y equals 3 for our reciprocal function. And so you can see how our graph looks like. Let's see, I don't know if it will match precisely for this, but this is how our reciprocal function graph should look like without the effect of the other graph. There we go. So that's the two graphs together. This is the reciprocal function without the other graph impeding. Okay, so that is what was expected out of question number. And here is the last question from the exercise. This is a question on sum and product of roots. Okay. To answer this question, so we'll start with part A. Part A, write down the value. So x1, x2, and x3 are the roots of a cubic function, which is f of x is 4x cubed minus 24x squared plus 35x minus 12. We are supposed to write down the values of x1 plus x2 plus x3, and part 2 is the product of the roots. So in fact, the first one is the sum of the roots, the second part is the product of the roots. Part B requires us to use that information to solve, use that to find the sum of the roots of the lower equation, which is basically an exponential equation. So let's start this by just dealing with part A of the question. Let's find the sum and the product of the roots. So the product, the expression x1 plus x2 plus x3 is called S1 in Vieta's compressed formula, where S1 is the sum of single roots, one here for single roots, okay? And x1 times x2 times x3 is sometimes called S3, the sum of triples. So if this was a polynomial with more than 3 roots, then we would be adding the product of roots in triples like this. All right, so S from the rule, we have that Si is -1 power I into an minus I over an. This is a polynomial of degree 3, and therefore we can write this as, so our A3 is 4. So first of all, n is 3, because the highest power of the polynomial there is 3. Its coefficient, the coefficient of x power 3 is A3. So A3 is that. A2 from there is 24. A1 is positive 35. And A0, the constant, is negative 12. Okay, so working with this, we can find S1. S1, meaning I is 1, is -1 power 1, sum of singles, into A3 an minus I. So 3 minus 1 is A2 divided by A3. So this is in fact negative of A2, so positive 24, negative of negative 24, divide by A3, which is 4. So our answer is clearly 6. So the sum of the product is 6. I can conclude there that x1 plus x2 plus x3 is 6. Secondly, the product of the roots S3 is negative 1 to the power of 3 into A3 minus 3 n minus I, but now our I is 3, so that becomes A0 divided by A3 according to the same rule here, and that gives me negative 1. Negative 1 power an odd number is negative 1 times A0. Our A0 is negative 12 and our A3 is 4, so this gives me 3. So S3 is 3. We are saying that the product S1 by X2, X3 should be 3. So that is how we solve the first part of the problem. The key rule that we need to be able to use is this one here, which is Vieta's formula. This is Vieta's compressed formula, so instead of thinking of all the roots separately, we use this compressed form of the formula and try to understand it. It makes life very easy to get this question right. Okay, let's look at the second part of the problem. And here is the last part of the question. Let me just write down the results we got from the previous part. So from part A, we found that the solution to the function f of x, so the three solutions, the sum x1 plus x2 plus x3 was 6, and the product of the roots x1 times x2 times x3 was equal to 3. So this is what we found. Now if you look at the second part, you can see that the function is actually an equation, resembles f of x. In fact, that if f of x is 4x to the power of 3 minus 24x squared plus 35x minus 12, then our new function here, basically an equation, can be expressed as 4e to the power of 3, or in fact, better still, fix it directly, e to the power of t, and we can say cubed so that it resembles this, plus or minus this is 24 e to the power of t squared plus 35 e to the power of t, and we can say minus 12 equals 0 by moving this 12 to the other side of the equal sign. So clearly this resembles f of x, in which case we can let x be equal to e power t. And therefore, if x1 is the root of f of x, then e power, so x1 would be equivalent to e power t1, right, where x1 is the root of this, of the original function, and e power t is one of the roots of our new equation. X2 would represent e power t2, where t1 and t2 now are the new roots. X3 would be the equivalent of e power t3. Now, if we are going to get the sum of the roots, because the question says find the sum of the roots of this new equation, so that the roots would be t's, and so if we're going to get t1 plus t2 plus t3, we have to multiply x1, x2, and x3. Therefore, x1, x2, and x3, which is the same as 3, is e to the power of t1 times e to the power of t2, t2 times e to the power of t3, which is the same as e to the power of t1 plus T2 plus T3, and this is equal to 3 according to that part. Yeah, and so we can conclude that e to the power of T1 plus T2 plus T3, this is equal to 3, and therefore T1 plus T2 plus T3 must be ln of 3. And this was the final answer for this particular problem. Thank you very much, guys. See you for the next one.